So suppose in the simple circuit with resistance, so this is your R, and the inductance, this is your L. If the battery give your voltage of 60 watts, so this is your electromotive. The switch is closed when time equals to 0, so that current is your I, in terms of time is 0. So give the current in the RL circuit is R di dt plus Ri equals to electromotive force in terms of time. Therefore, find your current, means solve your dE. So first of all, we substitute your inductance here is 4. And then your resistance here is 12. And your electromotive force here is 60. So the first one, we get this dE, and this dE can be simplified by dividing to 4. So di dt equals to 12 divided by 4, 3, and divide by 4, 15. So this is our dE here. And then we have to solve this. So, and then we find the current after 1 second. So when t equals to 1, what is your current? And your limiting value of your current means after you open this electric circuit for a long time, so when t approximates infinity, they ask you what is your current. So for the first one, A, the dE here, when we express it back to the right hand side, you can notice here only having variable I. So I will solve it by using separable, because variable t don't have. So this is all the factor of I. The t only have 1. So we move the factor of I to the left hand side, and then the tt, we multiply it to right hand side. Then we integrate both sides to find out what is your current, what is your solutions here. So to integrate this fraction, we get ln. And then this denominator here is linear, so we divide by the coefficient -3. Then integrate 1 here is t plus c. Then simplify, multiply this 3 up to the right hand side. So 3c, we remain it as c. Then we simplify the ln here. So we have a base e to the right hand side, and the function here become power. Then we simplify the power. So e -3t power plus means it multiplies with the same base of the power c. So finally this is a e -3t, and we still can simplify until we get the current I. So -15 finally. So I will be equals to a divided by -3, still a constant. And then this one divided by -3 will be plus 5. So this is our general solution for the current. Then we have to find out what is our particular solution, means we have to find out what is our constant A here. So in electric circuit, which is involving your variable time and current, it always have an initial state where time is 0. When you haven't switched on the circuit, the current is 0. So our initial state will be substitute t0, current 0, so that we can get particular solution from here. So substitute 0, 0, it will be A equals to -5. Therefore, our particular solution, -5 E -3t plus 5. So particular solution. For question B, then only we answer the question B. They say find the current find the current after 1 second. So when t equals to 1, what is the current I? So this one we just evaluate it by using calculator. So current ampere unit. Then for question C, what is your limiting value of current? What's your current? So when your time, what's your current? When your time is approximate to infinity. So we will analyze using the particular solution. When t infinity, we rewrite this exponential of the power negative back to denominator so that we can evaluate the infinity correctly. So when t is infinity means e will be power of infinity because 3 times infinity infinity. When e power of infinity, it will be infinity, still infinity. So you can see a number divide to an infinity, it will get 0. So that's why from the beginning of the question, when you have power negative, we rewrite back to the denominator so that we can operate the infinity correctly. So lastly, your current is 5 ampere. So this is your limiting value of the current. Limiting current I equals to 5 ampere.